So today we're going to look at how you can use some properties specifically associated with the natural logarithm. And by natural logarithm, I'm talking about this term here. This ln stands for natural logarithm. And we're going to use those to solve some exponential functions, to actually figure out what the input variable in a certain function should be to get a specific output. And then when we get to the next slide, we're going to look at how this is actually going to be useful for our word problems. Let's talk first about this first property. The natural log of a raised to some power is the same thing as that power times the natural log of a. And we're going to look at how this particular property is useful to solve an exponential function. So let's look at a first. 4 times 5 to the x equals 15. And we're somehow trying to figure out what x equals. So the first thing I notice here is, okay, we can use division. So what we get is 5 to the x equals 15 over 4. We can actually just leave that as a fraction. We're going to let the calculator in a little bit help us out, and you'll see why I'm saying that in a minute. We're going to leave that as 15 over 4 for now, since 4 does not divide in evenly. And then we're going to use this property here. So algebraically speaking, we know as long as we do something to one side and we do it to the other side, the equation stays equal. So what we're going to do is actually take the natural log of each side. So the natural log of 5 to the x equals the natural log of 15 over 4. And using that property, what we actually have is x times natural log of 5 equals natural log of 15 over 4. And then we solve multiplication with division. So we're going to divide by the natural log of 5 on each side. And x equals the natural log of 15 over 4 divided by the natural log of 5. And once we get to this point, you're going to need the video below about solving exponential functions with the natural log using a TI-84. And we're going to talk about how you would find this value here in the TI-84. But that value will come out to 0.821 if you round to 3 decimal places. Okay, so let's move on to B. For B, we're going to use this property here. That is, if you do the natural log of e to some power, it actually comes out to be that power. The natural log of e to the x, the natural log and e just cancel each other out and you end up with x. So we're going to use that idea here. Okay, so we want to solve part B for x. So the first thing I want to do is get it so it's actually just e to a power in itself. And so we're going to divide by 7. And 7 does go into 28 evenly. So this is 4 equals e to the 0.4x. And now we're going to use this natural log property over here. And we're going to do the natural log of each side. So the natural log of 4 equals the natural log of e to the 0.4x. And so what this property here says is that when you do that, the natural log will cancel this e out. And so what you actually have is the natural log of 4 equals 0.4 times x. And so we solve that by dividing by 0.4. X equals the natural log of 4 divided by 0.4. And here we'd use our calculator, and this number comes out to 3 decimal places to be 3.466. Okay, so why are those useful? And I'm going to give you a little hint. This specific example is going to go with part D from your written assignment, that 1.5/1.6 assignment. a population is modeled by the following function. P of t equals 4.58 times 1.034 to the power of t. And here we're saying this population is in millions, and t is the number of years since 2000. So during what year did the population reach 7 million? So what we want is P of t, the population, to be 7 million. So now we're trying to solve 7 equals 4.58 times 1.034 to the t. And hopefully what you're noticing is that basically looks exactly like part A. And so we're going to solve this for t using exactly what we did in part A from the previous example. We're going to first divide by 4.58. And obviously 4.58 doesn't go into 7, so we're just going to leave that. 7 over 4.58 equals 1.034 to the t. Now we take the natural log of each side. And we have that property where that can come out in front. So the natural log of 7 over 4.58 equals t times the natural log of 1.034. We divide by natural log of 1.034. And then using our calculator, we'll get t equals, to 3 decimal places, 12.688. Well, we need to think about the question. What does that mean? This is during what year did the population reach 7 million? Well, t is the number of years since 2000. So what this tells me, and I wouldn't round this number because it's just part of a year. So this is 12 years and an additional part of a year. So what year are we actually in? We're in 2012, and then we're in some portion of that year. So the answer here would be that we are in 2012 when the population reaches 7 million.